Hi students, class 10, exercise number 1.4, question number 2. Let f from a to b, a function from a to b be a function defined by, the function is given as f of x is equal to x divided by 2 minus 1. Where the set A is given as 2, 4, 6, 10, 12 and then set B is given as 0, 1, 2, 4, 5, 9. Represent the function f by, see the first one is the set of ordered pair. We want to write in the set of ordered pair, and then second one number is in a table form and then an arrow diagram and then a graph. The given functions can be represented like this in this form. We want to write the representation. First, the given function f of x is equal to x divided by 2 minus 1. That is the given function. Right? The function from a to b is given. The function from a to b is given. So we have to take the first set a as the domain set. So first set a element as the x value. So here a is equal to 2, 4, 6, 10, 12. By the function a to b, right? Suppose in case b to a is means first you have to select b as the domain. Next we have to substitute the value of x in terms, then f of 2 in the place of x I apply the value 2, then we get 2 divided by 2 minus 1, 2 divided by 2 means 1, 1 minus 1 is 0, right? Then f of 4, second element is 4, f of 4 means in the place of x I apply 4 by 2 minus 1, 4 divided by 2 is nothing but 2 minus 1 is 1. Next, f of 6. In the place of x, 6 divided by 2 minus 1 is equal to 6 divided by 2 is nothing but 3 minus 1 is 2. Next, we have element 10. So, f of 10 is equal to 10 divided by 2 minus 1. 10 divided by 2 is nothing but 5. 5 minus 1 is 4. The last element is f of 12. Here we have the 12 divided by 2 minus 1 is equal to 12 divided by 2 is nothing but 6. 6 minus 1 is equal to 5. Now we want to write this given elements and the function we have write in the ordered pair. First I write in the set of ordered pair form. The set of ordered pair should be in the form function is given as set ordered pair. We know that the 4 here we have 2 comma 0 is the ordered pair, right? When the function is 2, its output will be 0. The function of 2 it gives the elements 0. That is f of 2 is mapping with the element 0, right? So then the ordered pairs are 2 comma 0 and then 4 comma 1. And then 6 comma 2, then 10 comma 4, last one is 12 comma 5 is the ordered pair, 12 comma 5. This is the ordered pair. Next we want to write the given set, right? The function should be in the form of table form. Second one, a table form. Right? In table form means you know that the first value is x, the second value is function of x. We denote as f of x. See the x value is, we know that a is the domain set, so domain value of the x value. Here we have 2, 4, 6, 10, 12 are the domain. 2, 4, 6, 10, 12. That are the x value, right? Now the function of x. See 2 is mapping with element 0 and 4 is mapping with 1. 6 is mapping with 2. 10 is mapping with 4. 12 is mapping with 5. These are the function of f of x. Next we want to find out an arrow diagram. Here the third Roman number is an arrow diagram. and then second set. The first set is A and then second set is B. The first set elements are 2, 4, 6, 10, 12. And then the set of B is 0, 1, 2, 4, 5, 9. 0, 1, 2, 4, 5, 9. The function is represented, right? See, when we find out the function f of 2 is equal to f of 2, the function of 2 is mapping with the element 0. Right? In this form we have to write that. Or otherwise we go through the order pad also. By using the order pad we can mapping the elements, right? This is the function of f of x. Now 2 is mapping with 0. 4 is mapping with 1, and then 6 is mapping with 2, and then 10 is mapping with 4, and then 12 is mapping with 5. So this is an arrow diagram. Finally, last we want to show that in the graph form. Problem number 4, a graph. Here we are not using the graph sheet as it is. By approximate value only we are drawing here. Let me take this. This is x and y axis. Right? Here see, the A is the x-axis value. We get 2, 4, 6, 10, 12. I take this 2, 4, 6, 8, 10, 12. Right? And then the B value is 1 to 9. Then we will start from here 0, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Here also we get 14 extra. Now we want to plot the points means here we have the ordered set of ordered curve, right? Now take this set of ordered curve to plot the point. 2 is mapping with 0, right? The x-axis is 2, y-axis 0. This is the origin, right? X-axis 2, y-axis 0 means the point lies on x-axis. This is the point 2, 0. Right? Next 4, 1. In the x-axis is 1, y-axis 4 means this is the line. So this is the point 4, 1. Next 6, 2. X-axis 6, y-axis 2. Here x-axis 6, y-axis 2 means the point is lies here. This is the point 6, 2. Then 10, 4. X value is 10 and the function is 4. That is y value, right? X value is 10. Y axis 4 means this is the line. So it is the term 10, 4. That is the point. Location of 10, 4 and then 12, 5. So this is the y-axis 5, x-axis 12. Then this is the location of 12, 5. These are the form of the function is represented in different methods. Set ordered curve, and then table, and arrow diagram, and then a graph. Hi students, class 10, exercise number 1.4, question number 5. Show that the function f from n to n, natural number to a natural number, defined by, the function is defined as f of m, the function of m is equal to m square plus m plus 3 is 1 to 1 function. We know that 1 to 1 function means in a domain each and every element has unique element in the mapping element in the codomain. Then only we can say it is a 1 to 1 function. Let me take as the function as f of m. Solution. The function is given as f of m is equal to m square plus m plus 3. We know that natural number means start from 1, right? 1, 2, 3, it goes on, right? Here the function n to n means the domain is also a natural number and the codomain also a natural number. Let me take this. For example, we show that the function in the place of m I am going to apply the value of the natural number, right? 1, 2, 3 like this. Now first I take the function of 1 is equal to in the place of m I apply the value 1. Here 1 square plus 1 plus 3 1 square is nothing but 1. Then 1 plus 1 is 2. 2 plus 3 is 5. We get the function of 1 as the image is 5. Next, function of 2, f of 2, right? Here 2 square plus m plus also 2 and then 3. Here 2 square is 4 plus 2 plus 3 is 5. Then this value is equal to 9. So the function of 2 is mapping with the number 9. Let me take this f of 3 is equal to 3 square plus m plus is 3 plus 3. Here 3 square is 9. 3 plus 3 is 6. This term is equal to 15. We want to prove this term function is not equal means function of x is not equal to function of y. Then we can say it is a one-to-one function, that is x is not equal to y. Now clearly see that the function of 1 is not equal to the function of 2 because the mapping element is 5 and then 2. The function of the element 1 is 5, the function of element 2 is 9, and also the function of 1 is not equal to function of 3. Clearly we cannot get the same elements in the images, right? So by this condition, this is 5 is not equal to 9 and here 5 is not equal to 15. By this condition we can say this is a one-to-one function by through the arrow diagram also, right? Through the, this is 15, right? F of 3 is 15. F of 1 is 5 is not equal to 15. And then by through the arrow diagram, both are the natural number. We know that it is n, the function f of m. The function is here f of m. Natural number means we know that 1, 2, 3, and then it goes on, right? Here also the same. 1 and then I take this number 5 and then 9 and then 15. In between they have the numbers, right? Just writing the what are the mapping elements only. See, the function of 1 is mapping with 5. The function of 2 is mapping with the number 9. The function of 3 is mapping with the element 15. See, in the domain, each and every element has the image. That image is a unique image, distinct image. So the function is one-to-one function. Hi students, exercise number 1.4, question number 9. If the function f is defined by, the function is given f of x. Here the functions are x plus 2 and 2 is also a function and then another x minus 1 is also a function. See, this function x plus 2, then you are going to use mean the number x is greater than 1. The value of x is greater than 1 means we can use this function. And then if minus 1 less than or equal to x less than or equal to 1 means you have to use the function 2. Here x minus 1, we want to use the function of x minus 1 means if the x is greater than minus 3 less than minus 1. See, for this function, I write it here. You want to use the x plus 2 means x is greater than 1. X is equal to 2, 3 and then goes on. X is 2, 3, it goes on the values greater than 1 means. Now we want to find use the function 2 means x is greater than or equal to minus 1. So x is equal to minus 1 less than or equal to 1. Less than or equal to 1 and then including 0. Right? Including 0. Greater than or equal to minus 1, less than or equal to 1 means minus 1, 0 and 1. Right? These are the values we can use for the function 2. Then x minus 1 means the x is greater than minus 3. Greater than minus 3 means x is equal to minus 2. Less than minus 1. Less than minus 1 means only minus 2 and then in between the elements. First we want to find the value of the first Roman number function of 3, f of 3. Solution, the first Roman number we want to find out f of 3. the given function f of x, when we can use the function x plus 2, it gives x is equal to 3. X is equal to 3 means we are going to use this function only. So here we take f of x is equal to x plus 2. In the place of x, I am going to apply the value 3. Here 3 plus 2 is equal to 5. So the function of 3 is equal to 5. Next Roman number, the function of 0. F of 0. Here the function f of x is equal to, where we get 0, see in the second function, right? So it is the second function, then x is equal to 0 means we have to use the function as 2. So f of x is equal to 2, then the function of 0 is equal to 2. The third Roman number, f of minus 1.5. See where it lies the number minus 1.5. The minus 1.5 is less than minus 1 and then greater than minus 2. See, it lies in between that number minus 2, right? The third function. So the function f of x is equal to, how to choose the function f of x is equal to x minus 1. Clearly the numbers are minus 1 to minus 3 means greater than minus 3, less than 2, less than minus 1, right? So we get minus 2 and then below that number also minus 1.5 less than means also minus 1.5 also there. Minus 1 less than that number means we get minus 1.5 also. So we choose this function f of x equal to x minus 1. In the place of x, I am going to apply the value minus 1.5. Here we put minus 1.5 minus 1, both having the negative symbol. So put minus symbol, add the numbers, that is 2.5. So minus 2.5 is the value of the function minus 1.5. Next, the fourth Roman number, we have f of 2 plus f of minus 2. See, here we have two functions. 2 means in that there is a function, first one x plus 2. First we want to find out what is the f of 2. We have already have found out, right? So right here x plus 2 is the first function for 2, and then minus 2 means here it is the x is equal to minus 2. So the function is x minus 1. So first we find out what is f of 2. F of 2 means we use the function as first one x plus 2. In the place of x, I am going to apply the value 2. 2 plus 2 is equal to 4. Next, f of minus 2. F of minus 2 means here it is the value of x is equal to minus 2. That function is x minus 1. So this is x minus 1. So in the place of x, I am going to apply value minus 2 minus and then minus 1, right? This is equal to minus 3. Now we want to find out sum of these two functions, f of 2 plus f of minus 2. So f of 2 plus f of minus 2 is equal to, f of 2 value is 4. Here we have plus into minus is minus, f of 2 value is minus 3, right? So this term is equal to 1. That is the answer. Hi students, exercise number 1.4, question number 10. A function f from minus 5, 9 to a real number r is defined as follows. Give the function f of x is given as 6x plus 1 if x is greater than or equal to minus 5 less than 2. And then 5x square minus 1 if x is greater than or equal to 2 less than 6. And then 3x minus 4 if x is greater than or equal to 6 less than or equal to 9. Here we want to find out the first, second and third, fourth Roman number. First we want to find out how to find the appropriate functions by using the number like here. See, the given term is minus 5 to 9. So I have minus 5 and then 9. Now come to the functions here. See, x is greater than or equal to 5 and then here we have 2. I take a number 2 and then 6 in the next function, right? So where it lies, 6x plus 1, the function is lies between minus 5 to 2. Lies between in these two functions, that is 6x plus 1. And then 2 to 6. 2 to 6, the function is 5x square minus 1. And then 6 to 9. 6 to 9 is the function lies between the number 6 to 9 is 3x minus 4. So now see the first one our number f of minus 3 plus f of 2. F of minus 3, where it located in the minus 3 means here it is the place minus 3, right? So we want to use this function here. I write the elements minus 5. X is greater than or equal to minus 5 means minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1. Because less than 2 only. So if in the function these elements are appear means you have to use the function as 6x plus 1, right? Next one, here x is greater than or equal to 2 is the condition. So we take the number 2 and then less than 6 means up to 5. 3, 4, 5. These are the elements for this function f of x square minus 1. And then finally we have greater than or equal to 6. So we have to choose the number 6 less than or equal to 9 up to the number 9. 6, 7, 8, 9. Now we go to the sum. So the first common number is given as f of minus 3 plus f of 2. Function of minus 3. See, here it is the minus 3. So we have to use the function as 6x plus 1. So the function of x is equal to 6x plus 1. In the place of x, I am going to apply the value 3. F of minus 3 is equal to 6 into minus 3 plus 1. 6 into minus 3 is minus 18 plus 1 is equal to minus 17. Now we want to find out what is f of 2. F of 2. To find f of 2, where is the f of 2? 2 is here. So we want to use the function as 5x square minus 1. The function is 5x square minus 1. So in the place of x, I am going to apply the value 2. 5 into 2 square minus 1. 2 square is nothing but 4. 4 5s are 20 minus 1 is equal to 19. Now we want to add these two functions, right? So f of minus 3 plus f of 2 is equal to f of minus 3 we have found out minus 17. Here we have plus symbol, so plus f of 2 is we have found out that the element is 19. The function of f of 2 is 19. When we subtract this, we get 2. Next one. This is the second Roman number. See, the second Roman number is given as f of 7 minus f of 1. Function of 7 minus function of 1. See, the function of 7 is here. So we have to use the function as 3x minus 1 for f of 7. So f of 7 is equal to 3x minus 4. 3x minus 4 is the function. So in the place of x, we are going to apply the value 7. 3 into 7 minus 4. 3 7s are 21 minus 4 is equal to 17. Next we want to find out the function of 1. See, where it is the 1? The 1 is here. So we have to use the function as 6x plus 1. We have to use the function as 6x plus 1. So the function of 1 is equal to 6x plus 1 is the function. In the place of x, we want to apply the value 1. That is 6 into 1 plus 1 is equal to 6 ones are 6. 6 plus 1 is 7. Now we want to subtract these two functions, f of 7 and f of 1. Here f of 7 minus f of 1 is equal to f of 7 is 17 minus f of 1 is 7. So 17 minus 7 is equal to 10. Next we see the third Roman number, 2 times of f of 4 plus f of 8. Let me start here. Right, erase this. the third Roman number is 2 times of f of 4. 2 times of f of 4 plus f of 8. First we want to find out what is the function of 4. F of 4 is equal to which function we have to use. See, in this term, here it is the 4, element is 4. So the function is 5x square minus 1. So the 4 is occurring here. So we have to use the function as 5x square minus 1. In the place of x, I am going to apply the value 4. Then 5 into 4 square is 16 minus 1. 5 6 are 30. 0 remainder 3. 5 1s are 5 plus 3 is 80. 80 minus 1 is equal to 79. Then f of 8, function of 8. Function of 8 is equal to, see, here it is the number 8. So we have to use the function as 3x minus 4. 3x minus 4. So in the place of x, going to apply the value 8. 3 8s are 24. Minus 4 is equal to 20. Now we want to add these two terms. See, 2 times of f of 4. 2 times of f of 4 plus f of 8. So here we have the number 2. So apply 2. What is f of 4 value? F of 4 is here 79, right? 2 times of 79. Here we have plus. The f of 8 is 20. Now 2 times of 79 is 2 9s are 18, 8 remainder 1. 2 7s are 14 plus 1 is 158 plus 20 is equal to 178 is the answer. Next we see the last Roman number 4. See, the Roman number 4 is given. We want to find out 2 times of f of minus 2 plus minus f of 6 divided by f of 4 plus f of minus 2. F of 4 plus f of minus 2. First we want to find out one by one and then we have to find out the totally. Now f of minus 2. Here we are. Where it is the x value is minus 2. It is a minus 2. So we want to use the function as 6x plus 1. So 6x plus 1 is the function, right? In the place of x, I am going to apply the value 2. 6 into minus 2 plus 1 is equal to minus 1 plus 1. When you subtract, we get minus 11 is the value. Next, we want to find out the function of 6. See, here it is the number 6. Now, so we want to use the function as 3x minus 4. So 3x minus 1 is the function. So in the place of x, I find the value 6. 3 6 are 18. Minus 4 is equal to 14, right? Next, in the denominator we have f of 4. Function of 4. So the function of 4 we want to find out. See, where it is the 4, 4 is located here. So we have to use the function as 5x square minus 1 is the function. So 5x square minus 1. So in the place of x, I am going to apply the value 4. So 5 into 16 minus 1. 5 16s are 18 minus 1 is equal to 79. Next, f of minus 2. Here also f of minus 2. Here f of minus 2 is already we have find out. So we have no need to find out. First we want to find out 2 times of f of minus 2 minus f of 6 divided by f of 4 plus f of minus 2. Just what we have find out of the value, we are going to apply it in this term, right? Here we have 2 times of f of minus 2. See, here this f of minus 2 value is minus 11. And formula we have minus here, the given term minus f of 6. F of 6 we have find out that it is 14 divided by f of 4 is 79 plus f of minus 2 is minus 11, right? So plus into minus 11. When you substitute this, you get minus 22 minus 14 divided by 79 plus into minus minus 11. Both the numerator have a negative symbol, so put the negative symbol as it is minus. Add the terms, that is 36 divided by 69 minus 79 minus 11, right? 79 minus 11 is equal to 8, 68. And reduce to the lowest term. If it is reduced to the number 4 nines are 36. Here 4 ones are 28, right? 4 sevens are. Therefore, the value is equal to minus 9 divided by 70 is the value of this function. Thank you, students. Hi, student. Chapter 1, exercise number 1.5. Question number 2. Find the value of k such that f composition of g is equal to g composition of f. Here we have two Roman number. The function of x, f of x and then g of x is given. Usually, the f composition of g is always not equal to g composition of f. The commutative property of composition is always not satisfied. But here the condition is given as equal to. So first we want to find out the f composition of g and the g composition of x. Solution for the first Roman number, f composition of g. Right? Here f composition of g means f of g of x. That is the form. F of g of x. See, what is the value of g of x? The g of x is given as 6x minus k. So in this place, we are going to apply the value of g of x. So f of the g of x value is 6x minus k. Now compare this. It is in the form of f of x. See, compare this with f of x. In the place of x, we have 6x minus k. So in the place of x, we have 6x minus k means the function is 3x plus 2. So here in the place we are going to apply the value 6x minus k. The function is 3 times of, in the place of x is, here we have 6x minus k. So in this place also we are going to replace the value 6x minus k plus 2. Now 3 is multiple inside, we get 3 6 are 18x minus 3k plus 2. Let me take it as equation number 1, that is LHS, f composition of g. Now we want to find out what is the g composition of f. G composition of f is equal to, the formula is g of f of x. G of f of x. See, now f of x is given as 3x plus 2. Now compare this equation with the g of x. Let's see, g of x is equal to 6x minus k is given. See, in the place of x, here we have 3x plus 2. G of 3x plus 2. Here we have an x. So we want to replace the x value as 3x plus 2. We are substituting the x value as 3x minus plus 2. In this place, I am going to apply the value 3x plus 2. Then 6 into the x value is 3x plus 2 minus k. Now remove this bracket, we get 6 3s are 18x and then 6 2s are 12 minus k. Let me take this equation number 2. Now the given condition is f composition of g is equal to g composition of f. Now both the terms are equal, so LHS equal to RHS. See, LHS is 18x minus 3k plus 2 is equal to, and then RHS side 18x plus 12 minus k. Now take the x variable to one side and then constant to the another side. If I take this 18x to this side, we get Here we have already 18x minus 3k plus 2, right? I take this 18x to this side, we get minus 18x, and then if you take the whole term also it's possible. If you take the whole term here, this side means we get minus 12 plus k is equal to 0. Now 18x plus and minus value both are cancelled, and then here we have minus 3k. Here we have plus k. Minus 3 plus 1 is equal to minus 2k. Here we have plus 2 and then minus 12. When we subtract this, minus 10 equal to 0. Now, minus 2k is equal to, I take this 10 to other side, we get plus 10. Then k is equal to 10. It is 2, minus 2, right? I take to other side means it is division. Then k is equal to minus 5. Divide the terms, we get k is equal to minus 5. As the value. So this is the first Roman numbers value for f of g is equal to f of x. Next we see the Roman number 2 for the sum. Find the value of k such that f composition of g is equal to g composition of f. The second Roman number f of x is given as 2x minus k and g of x is given as 4x plus 5. First we want to find the LHS set f composition of g. F composition of g is nothing but f of g of x. Here the g of x value is given as 4x plus 5. Now compare this equation with the f of x. The f of x is 2x minus k is the given. So f of x, see in the place of x we have 4x plus 5. So here in the place of x I am going to apply this value. So this is the function 2x minus k. In the place of x we have 4x plus 5. So 2 into 4x plus 5 minus k is the function. Now multiply the 2 inside, we get 2 4s are 8x plus 2 5s are 10 minus k. Let me take it as equation number 1 or LHS set. Right? Next, the g composition of f. G composition of f means g of f of x is the form. Right? Now the f of x value is 2x minus k. Now substitute the value of f of x, that is 2x minus k. Now compare this with g of x. G of x is given as 4x plus 5. G of x is given as 4x plus 5 as the function. Now see g of x, in the place of x is here 2x minus k. So compare with this. So here in this place of x we have to substitute the value 2x minus k. So the function is 4 into the x value is 2x minus k plus 5. Now remove the bracket here, multiple with 4. 4 2s are 8x minus 4k plus 5. Let me take as equation number 2. Now we want to show that f composition of g is equal to g composition of f. The LHS set is 8x plus 10 minus k is equal to, the RHS set is 8x minus 4k plus 5. Now I take this whole term to left hand side. Here already we have 8x plus 10 minus k. If I take this whole term to this side, we get minus 8x plus 4k, and here we have plus, so change the symbol, minus equal to 0. Next, here 8x plus and minus both are cancelled. Then here we have minus k plus 4k. So 4 minus 1 is 3k. Here we have 10. 10 minus 5 is 5. The highest value is plus symbol, so we put plus equal to 0. We want to find the k value only here. 3k is equal to, I take this 5 to one side, we get minus 5. Then k is equal to minus 5. This is the multiplication. So if you take other segments, we get division. So the k is equal to minus 5 by 3 is the value. Student, class 10, exercise number 1.5, question number 6. Let f of x, the function is given as x square minus 1. Then find the first Roman number is f composition of f. And then second Roman number is f composition of f, right? Let's see the first Roman number first. F composition of f. F composition of f means the function is f of x. That is the form. The meaning for f composition of f is f of x is the form. Here f of x value is x square minus 1. Now compare this again. It is in the form of f of x format. Now compare with f of x. The function is x square minus 1. So in the place of x, we have x square minus 1. So in the place of x, we have to substitute the value x square minus 1. So x square minus 1 whole square minus 1. So it is in the form of a square minus b, a square, a minus b whole square form, right? So a minus b whole square is equal to a square minus 2ab plus b square. Now see, this is a, this is b. In the place of a is x square whole square, a square, right? Minus 2 times of a into b. A value is here x square and b is 1. 1 into that number is 1 plus 1 square is nothing but 1 minus 1. So plus 1 minus 1 both are cancelled. So we have here x power 4 minus 2x square. X power 4 minus 2x square is the answer. Next we see the f composition of f, right? Let's see the second Roman number, f composition of f. The function is given as f of x equal to x square minus 1. Here, f composition of f can be written as in the form of f composition of f. See, in the first Roman number we have already found out that f composition of f is the value is x power 4 minus 2x square. Now, here I take the value that is f of f is, this is the value x power 4 minus 2x square. Minus 2x square. Now compare this form with f of x. F of x is equal to, the given function is x square minus 1. See, now in the place of x, we have x power 4 minus 2x square. So here in this place I am going to apply the value x power 4 minus 2x square, right? Then this term is equal to x square is value x power 4 minus 2x square and then whole square minus 1 is the answer. Thank you, students.